Guys, in this video we are going to discuss what the heck we mean by radian measurement, okay? So when we measure angles, you'll always hear that we measure, of course, angles in degrees, but we also measure angles in radians. And radians at first tends to be kind of a difficult concept for people to grasp, but I'll be really honest with you, after we get done explaining it here, it will be a very, very simple concept, but what radian is, okay? And so I guess I'm gonna start this video with kind of going on about the purpose of finding radian measurement in the first place, and that is this. When you measure things in degrees, okay, so when you talk about the amount of rotation of something, of course, like 360 degrees is one full rotation, if you're gonna talk about that, or 180 degrees would be like a straight angle, or 90 degrees would be an upright angle or a right angle. But the bottom line is this: degrees are imaginary units, okay? So when we talk about units, we mean like centimeters. Well, centimeters is a given, unit of length, or like a light year is a given unit of distance as well, or just seconds, a given unit of time. A degree is a unit of measurement that is not necessarily a real number, and it's going to be the case that when we start to get into evaluating trig functions for specific angles, if you tried to evaluate a trig function for a degree measurement, it's nonsensical. Okay, a degree is a fictional unit of measurement. We want something that is purely real. So the rationale behind finding radian measurement will be the fact that radians, okay, it will be a real number. Simply put, real number. Okay, so that being said, let's go ahead and start by defining it. So we see this first definition here is the definition of what the heck 1 radian would be. Okay, so we'll go ahead and start by reading it, and then we'll illustrate what we mean by it. It says, in a circle, a central angle that cuts off an arc equal to the length of the radius of the circle has a measure of 1 radian. Let's go ahead and start with our circle here. Now this is just kind of, I'm sketching by hand, but here's my circle. We talk about a central angle as originating from the focus of the circle. So it doesn't necessarily have to be an angle in standard position, but let's say I have this angle right here, okay? And this angle right here, we're calling it theta, okay? In this instance, I'm saying that every circle, of course, has a radius, so we say r. It doesn't matter which radii we choose here, radial arm. We have 2 that are the same measure, and then we say, okay, in a circle, a central angle that cuts off an arc, okay? So the arc we're talking about it's cutting off is this arc on the outside of the circle here. That's our intercepted arc. And what we're saying here is, in this instance, the arc that it's cutting off happens to be equal to the measurement of the radius, okay? So I want you to consider this. We would say, if this is the case, if you were to rotate far enough on the inside of here so that you rotated just enough so that the arc you cut off is the same as the radius, then we'd say, okay, so in this case, theta is equal to 1 radian. 1 radian. So we might as well kind of, foreshadow a little bit here, but what would we necessarily mean then by, like, say, 2 radians? Like, how far would I have to rotate in order to get to 2 radians, okay? Well, if 1 radian means that the amount of arc that I've intercepted here, this amount of arc here, is equal to the radius length, then 2 radians would mean that, well, I must have gone, say, an angle that has intercepted twice that amount of arc, okay? So we'd say in this case, this arc up here has a length that is the same as the radius, and this arc right here has a length that is the same as the radius. If we were to measure now this angle, we could say this new angle here would be, say phi or something like that, and phi would have a measure of 2 radians. So we can basically expand this ad infinitum, but the bottom line is this: when we talk about radian measurement, we know one thing, that the radius of a circle never changes. So as I open up my angle more and more and more, what are the quantities that are actually changing here? Well, the more I open my angle, the larger the angle is. So like the more degrees you would typically be used to saying, we're moving on to radians now, but the more I open my angle also, the more arc I tend to intercept on the outside. So when we talk about what a radian is, we're really looking to see, well, if 1 radian is how many, how far I would have to rotate so that the arc was the same distance as my radius. Really what we're looking at is this: given a specific angle in general, how many times does the radius fit into the arc that you've intercepted? Because of course the more arc you intercept, then the larger your angle, but the larger your angle, the more times the radius fits into it. So what we'll do is we'll go for a very, very broad general definition now, and we say, okay, so here's our circle. Ooh, that was pretty good. Circle of radius r, okay? So we could say, all right, here's my angle, and we'll tend to start looking at things in standard position, so I'll be careful here, but we say, okay, so in general, we say this has radius r, and we're going to give arc length a letter. We tend to use the letter S for arc length. And then we have our central angle, maybe it's going this way, central angle theta. We can say in general this, well, if 1 radian means that I've intercepted just as much arc as the length of my radius. You know, the radius would be the same length as the arc I've intercepted. And 2 radians, well, 2 radians would be like the total arc I've intercepted out here is twice the amount of the original radius. And 3 radians would mean I've rotated so far that maybe I've intercepted an arc that is 3 times the size of the radius. In general, really what we're looking at is how many times does the radius fit into the intercepted arc? How many times does r necessarily fit into S? Okay, so given that, we say if a central angle theta in a circle of radius r cuts off an arc length of S, then the measure of theta, that is theta would be equal to basically how many times the radius fits into S. So we say in radian measurement, the number of radians you have rotated, instead of degrees, we'll go number of radians I've rotated, is equal to the amount of arc length divided by r, or in other words, how many times the radius fits into the arc length. It's basically saying, well, how many radians you've got, okay? So this formula right here, we want to make sure we have this written down, but that is the definition of finding the number of radians that you have rotated through necessarily, okay? So that being said, maybe we can play around with this a little bit, starting with this. Okay, well, if that's the case, what if I had a circle? You know, we call this like an example here, example 1. What if I had a circle, okay, and my central angle theta, we don't know, you know, say that maybe the measure of this angle, but I do know this. I have a circle of radius, and the radius is equal to, say in this case, 4 centimeters. And I rotated so far that I have swept out an arc length, and this arc length is actually, say, I don't know, 10 centimeters. We could measure that, you know. The fact of the matter is this. We call that S. We want to know how many radians we've actually rotated through. So what we could do is just say, well, how many times does 4 fit into 10? Because the definition of 1 radian would be, well, you've opened up so far that you intercepted, say, 4 centimeters worth of arc. How many of those 4 centimeter groups do we have? So really, we're saying if S is 10 centimeters and R is 4 centimeters, then the measure of this angle theta here, we better label this theta, is equal to how many times the radius fits into my intercepted arc. Because the longer that arc, the more I've rotated. So we say 10 centimeters over 4 centimeters. Now, a really important thing to mention here is this. When you line these up, your units cancel out, okay? So you end up with 10 over 4, same thing as 5 over 2, same as 2.5, and we're going to call this rad. Now, the interesting thing is, remember in the beginning I said a radian is a real number. So in this case, we'd say it's just a number, it's 2.5. The amount of angle you've gone through is 2.5. And people say, well, 2.5 what? Radians. But the fact of the matter is this. Rad is not a unit. It is unitless. This is a unitless measurement. So when people say, what's your angle? You can actually just say it's 2.5. 2.5 what? Radians. Do I have to label it with radians? No, we just mean that the radius, if you were to look at it, it fits into the intercepted arc 2.5 times. Okay, so maybe we look at, say, another example here. You know, we've got our circle of central angle theta. We'll go really big on this one. Maybe I head over to here, and I say, okay, so in this case, my radius is 2 feet on this circle, and the intercepted arc of my angle was really big this time. Okay, not all the way around, but we say S. And in this case, let's go ahead and let S be like 11 feet. 11 feet. So we say, well, then what's my angle theta? Okay, we can measure this in degrees, but I want a real number measurement. I just want to know, so how many times did this radius fit into the arc length? So we'll just divide. We save theta using our formula. Theta is S over R. We get 11 feet over 2 feet. We know that 2 fits into 11 5 whole times with the half left over. So we say this is 5.5 radians, okay? And I want you to know this, by the way, my picture is way not drawn to scale. But 5.5 radians, we'll find out here in a minute why. But 5.5 radians would be the measurement of this angle. What I would like to know is this then. Well then in general, how many radians are in a full rotation? Because what I can tell you is this. it doesn't matter what circle you give me. The larger the circle, then the larger the radius. But also the larger the circle, the more arc you're going to intercept. And so being a circle, the definition of a circle is something that is necessarily all the points on the outside of the circle are equidistant from the middle of the circle to the outside of the circle. Let me see if I can't zoom in here. Oh, that's not what we want. Let's close out of this guy. We'll try to do it over here. Okay, so we'll quarantine this off. But how many radians in a full rotation? How many radians in a full rotation? So we say example 3. Well, we know this. We know that given a circle, if we wanted to find the number of radians of our central angle, in this case we're saying a full rotation, we know that the radius is r in general. And we know that the arc length around the outside, okay, is s. We say s. And then theta is our central angle. And I should be switching colors here. So I'll switch colors now. But we say theta then, theta is equal to s over r. But what I would ask you is, well, what is the arc length of a full rotation of a circle? And that's like saying, well, that's the perimeter of the circle. In other words, we say the circumference of the circle. And we've got a formula for this. The circumference of a circle is 2 pi r. So if we wanted to know how many radians are in a full rotation of this thing, okay, in one full rotation, 360 degrees basically is how many radians. What we can do instead is, instead of writing, the arc length, which is s, which is 2 pi r in this case, we'll substitute that in for s. We get 2 pi r over r. That would be the arc length. We say how many times does the radius fit into one 2 pi r circumference. And so what you see here is that your radius, your radii, they cancel out, and you get 2 pi. So, man, I really wish I had some more room here. I wish I did. It's not wanting to cooperate with me at the moment. Let me see if I can't get this set up. So we say width. How about 4 by 6? I think is what I tend to use. Oh, I'm gonna need to. You guys are being so patient. I can tell you're being patient with me right now, and I appreciate that. We say 4 by 6. Try this out instead. Open that up. And that's very, very small. Maybe we could zoom in like a gajillion times. Zoom, 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 zoom. Well, unfortunately, I can't get that to work either. So let's go back to this guy, and we'll write down a few things that we want to keep in mind. So I'll switch colors for us here. Let's go over to like really bright green. But the fact of the matter is this. One full rotation we know is 360 degrees. We've just discovered that's the same as 2 pi radians. Okay, so one full rotation, 360, or 2 pi radians. So whenever anybody says 2 pi radians, you've rotated one full rotation. Okay, it's kind of an easy benchmark to remember. So what the heck would 180 degrees be? If we were to do a 180 degree rotation, 180, how many radians would that be? Well, that would be half of 2 pi, and half of 2 pi would just be individually 1 pi. 1 pi radian measurement means the same thing as 180 degrees. So let's scribble these down. We know 360 degrees is the same as 2 pi radians. Okay, so 180 degrees, and these are good things to write down in your notes, same as pi radians. So what would 90 degrees be? Well, if just from here to here was pi radians, then 90 is half of that amount. Okay, so we say 90 degrees would be the same thing as how many radians? Well, half of that pi, we just say this. We typically just say pi halves. Pi halves radians, half of a pi rotation. Keeping it going here, we say 45 degrees. Well, that would be half of pi halves. Half of our 90 is 45, so half of pi halves would be pi fourths. And so these are really, really good benchmarks to hold on to in the back of your head. Now, we also memorize pi thirds and pi sixths, and that'll be in my next video. But basically, this is just the roundabout gist of what a radian is. So what do I want you to get from this video? Well, a radian, 1 radian, is just how far you'd have to rotate so that the arc on the outside of the circle that you've intercepted is equal to the radius length. And in general, write this down, tattoo it on yourself. Theta in radians is always the arc length divided by the radius, how many times the radius fits in, okay? Oh, and these things, don't forget those.